In this video, we are going to discuss about TTL logic. So what does TTL means? Transistor Transistor Logic. So the question is, following are the specifications of the Schottky TTL 74LS 00 quadruple 2-input NAND gate. Calculate the fan-out, power dissipation, propagation delay and noise margin of the Schottky and NAND gate. So they have given the parameters and their name and their values. Okay. So suppose VCC means VCC is a supply voltage and they have given it is 5 volt. What is ICCH? It is high level supply current and they have given it as 10 milliamps, and ICCL is low level supply current which is 20 milliamps. So likewise they have given what is VOH. VOH is a high level output voltage which is a minimum value, that is 2.7 volt, and VOL is low level output voltage and the maximum value, that is 0.5 volt. Likewise VAL. VAL is a low level input voltage which is maximum and it is 0.8 volt. Likewise VIH. VIH is high level input voltage which there is a minimum value, that is 2 volt. Likewise IOH. IOH is a high level output current max, that is 1 milliamps, and IOL is low level output current max which is 20 milliamps. Likewise they are given IIH. What is IIH? Is high level input current maximum, that 0.05 milliamps. IIL is low level input current max, that is 2 milliamps. What is TPL? TPL means low to high delay, that is 3 nanoseconds, and TPHL is high to low delay, that is 3 nanosecond. So first let us discuss about power dissipation. So what is power dissipation? Power dissipation is it depends on the these parameters. Okay, one is supply voltage and observed current, that is from VCC when the output is logic 1, that is ICCH, or low, logic low, ICCL. Okay, next whenever the output current is on short circuit, that is IOS. Next PM represent this average power consumption. Okay, so what is power dissipation on EAC? Okay, power dissipation on EAC. So this is an important power component because it depends on the charging and discharging of the capacitance. Okay, so that is what is the power consumption during the capacitance. So PC is equal to F into CP VCC square. Okay, so here F represent switching frequency, and VCC is a supply voltage, and CP represents stay capacitance. Okay, next average power dissipation. Okay, average power dissipation. So this I can write it as PCC. Okay, PCC is equal to ICCH plus ICCL divided by 2. Okay, into VCC. Okay, so what is ICC? This I can also write it as PH plus PL divided by 2. Okay, what is ICCH and ICCL? ICCH and ICCL is 10 plus 20, that is 30 milliamps. Okay, VCC is 5 volt. Okay, so this I can write it as 30 milliamps divided by 2 into 5. Okay, so what is 15 into 5? 15 into 5 milliamps. Okay, so that is nothing but 75. This is your PCC. So if I want to find the total power dissipation, that is PM, that is equal to PCC plus PC. Okay.
Yeah, carry to the word through.
So for this, they haven't given the data like frequency and CP value and all. They haven't given. Okay. So here you can write this. Okay. This is your power dissipation. Okay. Next, let me go for the fan out and fan in. Okay. They have asked only about fan out. Okay.
Three. Three.
So first, let me discuss both. Okay. Fan out, that is second vectors F4. Okay. And the fanning. So these are the factors that is defined, which is based on some current values. Okay. That is correspond to the allowed input voltage and respectively to guarantee the output voltage. Okay. So I can write this fan out of load. Okay. FOL. I can write it as IOL, okay, divided by IIL. Likewise, FOH, I can write it as IOH divided by IIH. Sorry, II, correct. Output by input. Okay. So overall, FO value is nothing but minimum of this FOL and FOH. Okay. So what is IOL? IOL and IO is 1 divided by 0.05. Okay. IOL and IOH. T divided by 2. This is T divided by 2. Okay. This is 10 and this is if you multiply 100 you will get 20. Okay. So what is the minimum value of this 10 and 20? It is 10. Okay. So this is your fan out. So the next one is so this represent if you see if this NAND gate is connected to several another NAND gate means here the fan out values to okay. So next let me go for noise watching. So here NML and the NMH value will be there. So NMH is nothing but VOH minus this VIL maximum value minus VOL max. Okay, and this one is VOH minimum minus VIH NN. So noise margin is the peak amount of noise voltage that may be superimposed on a weak gate output voltage signal before the receiving gate might interpret it wrongly. Okay, so there are you can substitute this values. Okay, so this VIH is 2. Okay, what is VOH and VOL? VOH and VOL. VOH is 2.7, 0.5. 2.7 and 0.5. So this is 0.3 and this is 0.7. Okay. So here the I and O represent the input and output, and L and H represent low logic 0 and high logic 1. Okay. So if you see this is your VDD and this is your VOH value, and this one is VOL. Okay, and for input, if you see this is your VIH value and this is your VIL value. Okay, so this represent NML, this difference. Okay, VIL minus VOL. Okay, and this represent this difference. VOH minus VIH represent NMH. Okay. So this is your guaranteed value. Okay, this is your guaranteed values. Okay. So they haven't give the threshold voltage. Okay, the threshold voltage they have given it as 1.3. Suppose they have given VT value. Okay, VT is nothing but threshold value. Here they haven't given. Okay, threshold voltage is suppose if I assume it is 1.3 volt, and then I can write this real value. Okay, a real value NMH is nothing but
See, yeah, but I only thing in
VOH minus 8. Okay, and NML is equal to VT minus VOL. Okay. It is given by the charging and discharging time of the state capacitance from the gate output and by the switching times of the transistors. So I can write TPD, okay, that is equal to TPLH plus TPHL divided by 2, okay. So what they have given, three and 3, okay. So 3 plus 3 divided by 2, okay, nanosecond, that is 3 nanoseconds. If you want to find it for the short circuit current, okay, suppose they have given IOS. IOS is a short circuit current, that is 18 milliamps, okay. So they have given it as 18 milliamps. Sorry, current only, no, milliamps.
Believe that.
Instead of TPD, I need to find the TINC. So TINC value is CP into VOH minus VOL divided by IOH. This is the formula. Okay. So if the CP value and all given, you can calculate the this formula. And we know that TPHL. TPHL is equal to TC1 plus TDES. Okay. And TPLH is equal to TC2 plus T in. Okay. And then what is TDES means? Does CP into VOH minus VOL divided by IOL.